right. Welcome to the first lesson out of Module 1. Our last module we call him Mod 0 because it was kind of a review, get up to snuff type module. And now we're going to boot scoot boogie onto Module 1 where we're talking about triangles. And today we're specifically talking about the angles of a triangle. Our LT, I'm sure, is right up above, which in I will correctly identify and solve problems involving angles of a triangle. Boom. In other words, we're going to use things about angles to identify correct triangles and then solve for missing angles as well. All right, so let's get on with this. When you're looking at triangles, so I'm going to go through, best way I can do it online is to just go through some question types. Again, yours is going to be similar but different. So we have three different types of triangles we're talking about. We have an acute, obtuse, and right. Again, let me get out my drawing tools. Acute, right? And these are going to disappear whenever these disappear. My acute triangles are anything less than 90 degrees. And for it to be a triangle, all angles must be less than 90 degrees. For an obtuse triangle, that means greater than 90 degrees. And that is just one angle. So you have to have one angle that's greater than 90 degrees. And for a right triangle, right means 90 degrees. That looks like a 4. That meant to be a 9. Hey, I'm drawing with my mouse and I'm getting better. But for a right, again, that's one angle. So for a triangle to be acute, all angles need to be less than 90 degrees. By the way, if you don't know, this little L-shaped looking thing is a symbol for angle. For obtuse, at least one angle needs to be greater than 90 degrees, and for right, we need at least one angle equal to 90 degrees. So get that in your notes, pause this if you need to, and then let's move on, because it's about to go away, going, gone. And here's what we see. Let's look in here. Do we have any angles? We have less than 90 degrees, less than 90 degrees, up, greater than 90 degrees. 1 is all it takes, obtuse. Less than 90, less than 90, less than 90. If they're all less than 90, acute. Right up, 90 degree angle, doesn't even matter. It's a right angle. 90 degree, it's a right angle. See how that works? We can check it just to show you. What if I make a mistake? Nope, I didn't. Whoop, whoop. Hey, I make them laugh, and I'll keep them. We'll figure it out together. For each triangle, check all that apply. All right, so I'm going to do some more definitions here. For scalene triangles, it means all angles are different. All angles are different. For an isosceles triangle, oh, my voice went up. An isosceles triangle, two legs are congruent. And that's kind of a weird congruent symbol, but you get it. And last, we have equilateral. And for an equilateral triangle, all legs are congruent, as well as their angles, by the way. So all legs and angles are congruent. I'm going to put and angles. That'll matter at a later question. And for isosceles, the adjacent angles are congruent. So the angles adjacent to the congruent legs are also congruent. Okay? So in a scalene, all angles are different, all legs are different also. All legs are different. I'm just adding in stuff as we go. For the isosceles, two legs are congruent. Also, the adjacent angles to those legs are congruent. And then for equilateral, all legs and angles are congruent. So let's see what we mean here. You ready? Pause this if you need it. Going, gone. We have right here 7, 11, 7. Oh, 2 7s. That makes this isosceles. Boosh. Okay? 13, 13, 13. This is equilateral, but you know what? Are two legs the same as well? It's also isosceles. How about that? And then last but certainly not least, we have 6, 5, 4 or 4, 5, 6. All are different. This is scalene. Okay? Boom. Look at that. Can't remember if I'm doing question 3, but let's keep going. Yep, this one I want to talk to you about. So notice this one has angles in it. All right, if you notice that all the angles are the same, what do we know? This is equilateral, but you know what it also is? It's also isosceles. This one, right? Two legs are the same, and so we know it's isosceles. These are all different. That's going to be scalene. And we see two angles are the same. Hey, remember, if adjacent angles are the same, we know it's isosceles. Boosh. That's a good problem. I liked it. I'm going to work out a harder one. We're going to do a harder one than 4. We're going to go to 5. I like this one. Okay, let's get my drawing tools out here. All right, we need to find x. Here's what I know. Let me just highlight a nice little area. If I need to find x, ultimately I want this angle. But to do that, watch. I'm going to make this a little easy on ourselves. I'm going to highlight this big triangle. And I'm actually going to delete that. Oh. I wanted the big triangle. Here's why. Check this out. This is actually kind of cool. So vertical angles tell us that diagonal angles are equal. So I know this is 37 degrees. I know that all the angles of a triangle add up to 180. These two together make 69. So now I have 37, 69, and I want to know what this angle is, because if I do, I know that this is a supplementary angle, and I can easily solve for that. So check this out. 37 plus 69 is what? 99, 106. So I have 180 minus 106. Boom, and that gets me what, 74? So I know that right here I have a 74. Can't write it very good, but right there's a 74. I'll just do that though. Ah! What just happened? That is so sad. I accidentally undid everything. So what do we have? 37. This together was 69. Then I calculated that this is 74. You can always back up and pause if you need to see anything. And I want to find the complement here. Again, they add up to 100, or not the complement, the supplement. So these add up to 180, right? So I'm going to have 180 minus 74. What do I get? 106. There we go. This is actually going to lead to a property that's kind of cool, but we're going to talk about that as a different date. For right now, we're just going to go with this. X equals 106. Boosh. Check it out. 106. How'd I do? Boom. In the triangle below, with angle F, suppose that the measure of angle E is 4x minus 7. We see that 4x minus 7. And the measure of angle G equals 3x minus 8. Perfect. Find the degree measure of each angle in the triangle. So we need to both solve for x and then put it back in and solve for the angle, right? Now, we know all angles in a triangle add up to 180 degrees, right? But since this is a right triangle, and one of those angles is 90, what's 180 minus 90? It's just 90. So now I know these two angles should add up to 90 degrees. Let's talk about that. So I'm going to have 3x minus 8. I'm going to add to that the other angle, right? Plus 4x minus 7. And together, those angles should equal 90 degrees. Now, again, I'm just solving for x right now. So let's combine like terms. So I can combine, hey, there we go. I can combine x's with x's. What's 3x plus 4x? That's going to give me 7x. And then I have minus 8 minus 7. minus 15. And we know that equals 90 degrees. So I color coded that so you kind of see it. Again, I'm going to add 15. Let's just solve this like we would any equation. Y'all are great at those. I get 7x equals 105. And let's see, divide both sides by 7. I know that 7 goes into 10 once, leaves 35. 3 and a 5, so that's 35, goes in there 5 times, 15. Boom, 7 goes to 7 once, those cross out. I get x equals 15. If that's true, let's plug it into here. I'm going to have 3 times 15 minus 8, right? Which is 45 minus 8, or 37 degrees. Down here, I'm going to have 4 times 15 minus 7. That's going to be 60 minus 7, which is 53. And I can further check to see if these are correct, because what's 53 plus 37? That's 90 degrees. Boom. All right. Pause this if you need to. Gone. I think that's about all we're going to work through today. You have some good problems left, but you can work through them. Yeah. Nothing you guys can't work through. Ooh, did I go the right problem? Yeah, I did. You guys are doing great. This one's going to take just kind of following directions going down through, so just keep that in mind. But this is Angles of a Triangle. Are you guys ready? Peace out. And get your homework.